So the previous component we talked about was our hard disk drive or our long-term memory. Now we're going to get into our short-term memory. So things that are, things that you recently came across, then you say, "Oh, that's neat," but then it's not impactful enough to your life that you actually remember it in the long run. This could be anything from like a dream you had the previous night. You wake up, you're like, "Oh, that's so awesome." 10 minutes later, you can't remember any part of it. That's just the way it goes. It's in one side and out the other. Short-term memory. Now, what we're talking about here is called random access memory, or RAM. I'm sure every one of you have heard this before. This is our short-term memory, stuff that we're using at the moment. What does that actually mean? So let's have a quick discussion. Now, we know our hard disk drive is used for permanent storage, stuff that's stored permanently on our computer. Our RAM is stored for stuff is used for stuff that is in use right now. It stores temporary data in use at the moment. So let me explain that process for you just briefly. Basically what happens is, let's say you open up Word. What the computer does, the operating system will go to the hard drive, find all the files that have to do with running Word. It'll pull them out, and then it will copy them into our short-term memory, or our RAM. So it's in use right there at that moment. And the next thing will happen is you'll say, well, I also want to open up this essay file. Okay, so the operating system goes over to long-term memory, grabs that essay file, that Word document, brings it over to RAM and shoves it in RAM. It says, okay, now you're in use right now as well. So right now, at that moment, you have two copies of each of those things existing on your computer. One of them on your hard drive, which is safe, and one of them in your RAM, which is volatile. It's unstable. So we know that hard disk drives were non-volatile, which means power goes out, no problem, it's safe, it's stored with magnets, not an issue. However, here we're talking about volatile data, and that volatile data, well, this data, if the power goes out, this data is gone. It is gone. Why? Because RAM stores its data electronically. It doesn't store it with magnets or anything special. It's literally high voltage, low voltage kind of thing. So if you have no voltage, you've got no data. Well, that's a problem. What happens if you're in the middle of something and you haven't saved your work? Well, it's gone. That's it. It's gone. So operating systems and software have typically come up with ways to circumvent this and try and, alleviate the pain. I could tell you stories about lost data and whatnot, but in the last decade or so, most programs have implemented something called your autosave feature. And basically, every 5 minutes, your whatever program you're talking about, let's say Word, 5 minutes, when you can set the time limit usually, but usually every 5 minutes, the program will make a backup copy on the hard drive, just in case your computer crashes. And it will say, okay, we've got this backup. Let's say computer crashes, you come back on, you reopen Word, and it'll say, something happened, would you like to recover your file? And what's happening is it's going to grab one of your backups from the hard drive, and then it's going to pull that thing and put it into RAM again, make another copy of it for your editing purposes. And until you hit save, that original file on the hard drive is not replaced. You got to hit save. Okay? Once you hit save, everything is good, and it's stored permanently using magnets again on that hard disk drive. Now this, because data is stored electronically, that means that there's no spinning disks, there's no armature, there's no real seek time per se. There is some time taken, but relatively speaking to a hard disk drive, it feels almost instantaneous, almost. So this data is stored electronically, and it is considered primary storage. And this primary storage is called primary storage because it's the first place your computer is going to look for the information. But this can actually create problems. So let's say, for example, where's my pencil here? Let's say on your computer right now, you can see that I have two programs running. I have Whiteboard going on the left side, and on the right side, I got PowerPoint going. And these guys are going simultaneously. Now imagine in the behind the scenes, I also have Photoshop going. And maybe a video editor as well. And I do. But am I using that stuff right now? Oops. Not really. Not at this exact second. So what'll happen is, sometimes, depending on how much RAM you have, how much memory your computer actually has. Maybe your computer has, let's say, I don't know, 4 GB of RAM. Well, let's say PowerPoint requires, I don't know, let's say PowerPoint requires 600 megabytes. And let's say my Microsoft Whiteboard over here requires 200 megabytes. These are probably overshooting here, but whatever. Let's say Photoshop requires 2.5 gigabytes. Now if we combine these two, we're sitting at 0.8 gigabytes. And now let's say my video editor, which is a beast, probably takes, let's say, 3.2 gigabytes. Oh man. Now let's think about this. Now if we add all that up, we got 5.7, that's 6.5 gigabytes that should be in my RAM right now. But I only have 4 gigabytes of RAM. How does the computer handle this? It doesn't just say, nope, I refuse to open stuff. No, it won't do that. What it does is it does something called paging. Now this is definitely not part of the course, but it's an interesting piece of information. So what paging is it says, okay, which things are currently in use, like actually in use at the moment. So right now it sees that I have Whiteboard and I have PowerPoint currently in use at the moment. And then it's going to go and then it's going to say, okay, what's the next thing that's used relatively recently? Well, that's Photoshop. So right now we're looking at 2.5 plus 0.8. So these three together are looking at, what is it, 3.3? 3.3 gigabytes. Well, I don't have the other point, I only have 0.7 gigabytes left, which means this 3.2 gigabytes can't be staying on RAM. So what it does, the paging will say, okay, let's grab this, let's throw it in the hard drive. All right, so it kind of throws it in a temporary spot on the hard drive. It doesn't overwrite the original data, it just throws it in a temporary spot on the hard drive, so it's kind of there. And then when I switch over as a user, let's say I switch over and I minimize a couple of my windows. Let's say, for example, I minimize Photoshop and maybe one of the other programs. Those things I minimize. Let's say I minimized this guy and I minimized this one. So my PowerPoint and my Photoshop. So it's going to take this 3.1 gigabytes and it's going to throw this into the hard drive. And this guy, when this happens, this one's going to come back into memory. So they're basically swapping positions back and forth. And the more times I move between programs, it's got to do this paging process. Now we know that a hard disk drive is super slow, especially relative to RAM. So what happens is you'll actually visibly see your computer slow down. And it's not the CPU that's slow. It's actually the data access going back and forth between your hard disk drive and your RAM, this paging process. So a lot of times people will say, oh, my computer's so slow, my computer's so slow. Well, no, your computer's as fast as it always was. The thing is that you just have too much stuff open. And if you have too much stuff open, you don't have enough RAM to support that, well, your computer's going to slow down because of this paging process. So what's the solution? Well, there's a few solutions. The most obvious solution would be to get more RAM. And no, you cannot download more RAM. But you can purchase more RAM if your motherboard supports it. Your motherboard will have an upper limit of how much RAM it can hold. Now, if you see you're starting to reach that upper limit, it may be time to get a new computer or a new motherboard, depending on how tech savvy you are and comfortable with replacing your parts yourself. But yeah, that's really why your computer is typically slowing down. It's not because your computer is getting slower. The computer is as fast as it always ever was. It's just the way things are. Okay, so this is primary storage, your RAM, and it's for data, temporary data that's in use at the moment. Let's go back here. So how does it work? As I said, it stores data electronically, and data is accessed. So in our previous analogy, where we had the platters spinning and whatnot, and we said if I wanted to get my favorite part, you had to hold that fast forward button and seek to it. Well, RAM works in a different way. RAM works more similar to like the scene selection on a DVD. Oh, my favorite part's in this scene, so I'm just going to pop right to it. It's instantaneous. Or direct access. Now, direct access, well, that was called random access. And this is where as a high school teacher, I have issues with this term random access. Now, random access, what it really means is that it can go to a specific spot. Okay? Now, as a student, typically you say, well, that's not what random means. Random means, I don't know, pull a number out of the hat and see if it's the right one. So RAM does not work by randomly jumping to a place in its storage and saying, is this what I want? Oh, let's try another one. Is this what I want? No, that would be crazy slow. Like your, what is it, the BOGO search? Uh, Google it if you want. Anyways, so it doesn't jump to a random location. It jumps to a direct location. Well, why don't they just call it direct access memory? Well, dad joke of the day, because you don't want to tell buddy to go buy more damn RAM. More damn memory? More damn stuff. Too much dams there. Anyways, terrible joke. And the delivery of it was even worse. Superb. All right, moving on. So where is RAM located? RAM is all about speed, baby. So if you got speed, you need to be connected directly to that motherboard. So it is literally inserted in the motherboard. So if you remember that picture that was at the top of the screen before, it was the slots at the bottom. There were 4 slots typically, and each one of these modules would plug into it. Now you see all these different looks of the RAM. That's because they're for different devices. Usually these first few are going to be for a desktop computer, maybe even this one. But this is typically your laptop computer here, and then this might be for something like, I don't know, a cell phone or something along those lines, right? Depending on what's going on. But all forms of computing devices require memory these days. So your next tidbit of information, bolded and yellowed. All right, in 1957, exactly 1 year later than the previous tidbit, the cost of RAM was $411,041.79 per megabyte. Not gigabyte, megabyte this time. That means that if you wanted to compare it against the storage before, you'd have to shift that decimal place 3 more times. So it'd be $411 million per gigabyte of RAM. That's crazy. And the last one was $10 million per gigabyte, if you remember. So $411,000 per megabyte. Today, it's not even 1 cent per megabyte. It's less than 1 cent per megabyte. Crazy. Crazy. All right. So let's talk about what kind of RAM you need depending on what you're doing. So this is a chart that's based on the type of user you are. Okay, so the whole point of these discussions is to be able to accurately go and purchase a new computer or compare computers, or at least understand what's going on based on your resources available to you. So if you're the type of user who does large, complex software use, like databases, things like that, then you're going to need more than 4 gigabytes of RAM. Now, your standard computer nowadays usually comes stocked with about 6 gigabytes of RAM. Advanced games. If you're playing high-end graphical games, you're typically going to need more than 4 gigabytes, unless you're playing on some streaming service like Google Stadia, which does all the processing on their side and just send you an image. Simple games, things like on Congregate, or things that are on like Facebook games, that kind of stuff. You don't need a lot of RAM for that. And similarly speaking, same with internet browsers. You don't really need a lot of RAM for that. Everything is typically done on the server side, and then you just send imagery and whatnot. Programming. Now, because when we're programming, we're dealing with raw data, typically speaking, you need a fair amount of RAM to deal with this, especially if you're making games like you do in my class. Most office work, like Microsoft Office stuff, Word, Excel, PowerPoint, typically speaking, you don't need a lot of memory for that, but there are exceptions to that rule. So if you're dealing with super large Excel files, and that does happen when you're dealing with hundreds of thousands of items and rows, then yeah, you might need a fair amount of RAM. But if you're doing any form of other complex mathematics, it needs to be able to deal with that data effectively, so yeah, you're probably going to need a lot more RAM as well. Okay, so how much primary storage does my computer actually need? Well, your primary, so this is your RAM again. So how much primary storage does your computer need? Well, that depends on the type of software you're working with. Now, this again comes back to the whole point of you need to understand what you're dealing with. So, for example, various programs on your computer are going to have different requirements. So if you look at the side of the box, if you're buying it physical, or if you look on their website, it'll say minimum requirements. It'll say I need this much RAM. I need this much RAM. Now, think about how you're using your computer, how many things are going to be open simultaneously. So you're probably going to need more than just that RAM. So if you know, let's say Windows, as we see here, Windows requires typically about 1 GB of RAM as a minimum requirement, and then you're also going to have other software running simultaneously. That all stacks. So you got to think about this. How much RAM do I actually need? So anyways, type of computer. Your general purpose Windows PC, MacBook. These are computers that can do lots of different things. Oops, going ahead of myself. These things are do a lot of different things simultaneously. So you're going to need a fair amount of RAM on there because you're doing so much at once. Gaming machines, they need to push high-end media, so images and sounds and code and all that kind of stuff. That is going to require a lot of RAM. The more RAM, the more stuff can be seen on the screen, things like that. So most dedicated game machines, your Xbox One rocks an 8 GB amount of memory, but only 5 GB usable. PS4 similar, but only 4.5 GB. Nintendo Switch has a whopping 4 gigs. That's the end of the story. Smartphones range. I've tried to keep this as up to date as possible from when I made this PowerPoint. So if you're watching it at a later date, it's very possible that this data is old by that point. Anyway, smartphones are like general purpose computers. They're just like computers, so they require a lot of memory as well. So your iPhone X or iPhone 10, depending on how you say it, 3 GB. Google Pixel has 4 GB. Your Galaxy S10 has 8 GB. Whew, that is a lot. Dumb phones. What? Dumb phones? That's offensive. No, it's not offensive. A dumb phone just means a phone that can't do things like install apps and that stuff. They basically do two things. You can call and you can text. And that's it. Nintendo 64, just a little extra piece of information for you. Nintendo 64 only had 4 megabytes of memory. 4 megabytes. You could upgrade it up to 8 megabytes, which made a big difference. But 4 megabytes. Crazy. Not a lot of RAM needed there. All right, so we're going to stop there. We only have one more component to talk over, and then we're going to finalize everything, but we're almost there.